All right, here we go. Age of Conquerors. No, wait, sorry. Alexandria Ocasio-Cortez. No, wait, sorry. Advent of Code. Day 16 AOC. Let's do this. So I just read this over. Day 16 is interesting. You shoot a beam of light, and the light can hit mirrors and reflect at a 90-degree angle off them. Or if they hit a splitter, then they go in two different directions. And so you're probably going to need some sort of recursive ability to shoot a beam of light. And at the end of the day, you need to be able to mark what squares the beam of light traveled over. As always with recursive functions, you're probably going to need some sort of way of stopping it from just looping forever. So let's just get going and see what we can do with this. All right, so I'll just start with a blank file. Is my macro not working? That's fantastic. There we go. All right. So we've got this. We've got then map1.text. We're just going to dump that map file into it. We'll probably copy map1.text to be map2.text. Move map2.txt to map2.text. And maybe just create a really simple map just to start with that maybe we can just do something like this and just verify that the light is going to bounce the proper way on that. And then we will need map3.text. Thank you very much. That is from an old assignment. And that one is going to be the big boy here, which is this guy. Copy that. And dump this into map3.text. There we go. That's a thing. All right. So 110 lines. 8, 9, 10. 110 by 110. Okay. So what we could do is we could start off by hard coding the size of the map, but maybe we'll do this properly for once. And what we can do is we can see how big the file is. I think we can probably assume they're square. Let me just double check that. Map1.txt is 10 by 10. So we have a 10 by 10. We have 110 by 110. Yeah. So let's just assume that it's going to be square. Okay. So are we going to read it from standard input, or are we going to read it from a file? Let's just read it from a file. Let's do this. ifstream ends, and we'll just do file1.text like that. We'll just hard code the file, and then we can switch them out. In fact, let's just start a little dummy file to begin with. And then we will say int rows equals 0, while int is valid. String temp equals readline from ends. If ends became invalid, we're going to break rows plus, and then we're just going to see out rows. And I'm just doing this. This program here just counts how many rows are in 0. Okay. File2.text. Aha, map2.text. Should always check your code. All right, compile it, run it. There we go. So we got 10 rows in map2, and if we go to map3, we should have 110. There we go. Okay. And so always double check your stuff. Like, you know, I've been coding for a long time, but you know, I'm not immune to you know, typing the wrong file name in or anything like that. So what we're going to do now is we're going to make a vector of characters named vec, which is going to be of size rows, and each row is going to be a vector of chars of size rows. We're going to assume it's square because, you know, we're not accepting input from anyone else, so why not? Let's do this. Always assume you're stupid, phosphorus. Yeah. Don't trust anyone, especially yourself, right? So always get in that habit of testing, running, testing, things like that. So let's compile it, run it. Okay, cool. Yeah, let's just keep that in there just so we can remind ourselves. All right. So now what we're going to do is say for int I equals 0, I is less than rows, I plus plus, doubly nested for loop time, y2yp, it's indented a little bit, and make this also up to rows and j, and we will just say vector dot at I dot at j is equal to read from the file. Now you might notice, well, we've closed the file, so we could do a seek. I don't remember how to do that off the top of my head, so we're just going to do an ins close, and I would have to open up a web page. I'm just going to reopen the file. How about that? Ooh. We're doing this one properly. Look at this. Look at this. Look at how proper we are. Okay. D3W. File name. So we're just going to close the file. We're just going to reopen the file. And just open it a second time. And then when we're done, we're going to say for every const row in vec. For every row in the vector, y2y paste. For every character named C. Now let's do this. For every column in the row, we will see out a column, and we will see out the row. And if everything girlfriend not found, there you go. All right. Yeah. There we go. Don't type and talk at the same time. There we go. Okay. So, and take out the inline here. And there we go. So there is map 3. Bottom right corner looks like that. So map 3.txt. And a slash with 2 dots and slash with 2 dots. And okay. I feel reasonably confident in this. First one is a slash there. First one's a slash there. Okay. Seems like it's loading the map fine. Good times, good times. Let's go back to our dummy map here and just double check that one. And that looks like everything's lined up right. 1, 2, 3, 4, 5, and 4 afterwards. Okay, cool. All right, so we're loading the map just fine. And we'll just manually change the map when we're ready to go. So the way the advent code works is I think it starts in the top left corner. Yeah, top left corner from the left heading to the right. Okay, so what we need to do is shoot a beam that way. And what's going to happen is the beam's going to hit the splitter here, then it's going to go down, then it hits another splitter. One beam travels off the edge of the world that way. The other one travels here, hits a splitter, goes through the splitter, hits the mirror, goes up, goes there, goes down, splits left and right, split, you know, et cetera, et cetera. So we got a loop in here that we're going to have to handle. All right. So we're going to start off with just shooting a single ray. So we're going to come in here and in honor of ray. How many different rays do we have now? Yeah. All right. In honor of ray, we're going to have a function called ray. And ray is going to be a void function because no, if we care if it hits anything. It's going to be called ray. And raylib, Megan's husband, serial, my own middle name, all rays. Yeah. So we're going to shoot a ray, and we're going to need a location. We're going to need an integer row, an integer column, and a direction, which I guess if we're doing this properly, we'll do an enum. North, south, east, west, something like that, maybe. Direction. See how that looks. Okay. So the main is going to be just, oh, we're going to need a map too. Do we want to make the map global? Do we want to make the map global? Maybe we want to make the map global. Let's do it. Vector. Let's just do this. Okay. BD. This is not good coding style. Children don't do this at home. Right, we're gonna make a vector here. Then we don't need to pass it around. In fact, we can make a void load map function with a string file name like this. And then we can just toss all of this code into here. And the vec, so we'll do rows. Okay. So we will do a vec dot resize rows, and probably, yeah, I can do this. Vec dot at I dot resize 2 rows as well. So we're gonna just resize it to be 10 by 10 or 100 by 100. Let's see if that still works, huh? Okay, so our function down here could just be load map file name. Map2.txt. That. And let's see if that works. Or did we break it? Okay. Now let's try this with map3 and see if we work it. Nope, still works. Cool. All right. So this is just simplifying our code a little bit. You shouldn't use globals in general. If I was doing this for realsies, I'd pass it as a parameter, but this works. Okay, so we're gonna load map, and then our main is just gonna be array 0, row 0, column 0, and we're gonna be traveling east like that. And there you go. So Hanson, you remember enums? You remember what this is all about here? Good. All right. So we got 4 different directions. North is equal to 0. South is equal to 1. So that'll be nice. And then we've got our map loaded. So all we need to do now is just write this function here. And then once we're done with everything, you need to count how many squares were visited. Maybe we should make like a second, like if that's the original map, maybe we should make a second one like this, just so we can kind of like debug it or something like that. Or do we want to do it like this, where we just track the visited squares? Yeah, we should probably, because we're going to need something like that to avoid infinite looping. Okay. So let's make another map. This one will be called, names are hard, status. And I don't know. And this should be like a status class or something like that. Let's correct the status. So we're going to need to track vec1, vec2, vec3. Yeah. I mean, vec, realistically, we should call that map, right? It's going to break everything. No. We should call it map. Oh. Might even make a print map function or something. Print map. Auto. And then we can print either of them, you know what I mean? Okay. In case we want to print one or the other. And then we need to make the status map here, because that's going to need to track, because the same spot can be crossed 4 different times. It could be crossed with a beam of light going south, going up, east, or west. And if we ever do it a second time, then we stop. But if you have it going, like you could have it cross north. And so you can't just stop if you've been there before. You have to actually handle either at least 2 directions. I'll have to think about it, maybe 4. How do you print a status? Could use a char for it. And realistically, it's going to be like 4 booleans. Bool. So if this spot, we've gone south on it before, then south should be set to be true. That makes sense? Swagvec. Yeah. And then we'll just need to make sure this vector is the same size as the other one. So we'll make the map.resize, we'll make status.resize 2 rows, and YYP status. So we'll make sure it's the same size. And then all of these things are going to be initialized to false. And then we just need to figure out how we're going to print it. I guess we could follow their printing style here, where if it's only got a status of one direction, we print an arrow going in that direction. It's less than, greater than, v, or caret. Yeah, okay. Okay. So OStream operator, the left arrow, taking an OStream by reference named outs. And this needs to be a friend function. And a status. Be const status by reference named s. So we're going to print out a status. Then we'll need to, let's just return the out so I don't forget it. So it's kind of probably should have done this using a vector of booleans. Probably. Four is right at the threshold where, like, I have to decide whether or not I want to actually type everything out or just do a vector. Okay. What's done's done. Okay. So we're going to do what I'm doing here is I'm seeing how many directions this spot. A beam of light has traveled east, north, south, west. If it's been none of them, then that's one thing. It's going to be pretty bad, but okay, so if the count is greater than 1, then we will outs the count and return it. Actually, we'll just return because that's what we have over here. If the beam of light has traveled over the spot twice, which it has here, went like this or something like that, then it prints out the number. So that's what we'll do. We've covered it more than once. If the count is 0, then we'll just print out the corresponding map, which we don't need, which we don't know. You just copy it from the map. In fact, we might not even need map then. In fact, this could be map. Yep. Okay, simplification time. Here we go. Let's do this. Only need one 2D vector now. Return outs. Double arrow C. So we're combining the two now into one map. Stop C. And then I'll do the rest later. So let me just do this. We don't need status anymore. We don't need it anymore. Okay. In fact, I can just call it Vec again. Okay, so what I've done is I've combined the two. So the status, which is the number of different ways light has crossed each spot, I've combined it with the vector of characters containing the original symbol at that point. Could probably use an enum, make it a little bit cleaner, but I guess I'm okay with that. Let me just finish this. So, okay, so if we've gone past this point here, then only the count is exactly 1. Okay, so we just do this. If s.north return outs double left arrow caret. South is a down arrow. West is a less than character. And east. And that should be good. This should never happen, but it's a good safety measure to leave it in there just in case you screw up. So always, never not return something from a function. This should never happen. Okay, you just leave a note there. Maybe unused if you feel like it, but yeah, whatever. Okay. All right. So with this, see, it's not. Yeah, don't worry about it. What is it? So if you've ever seen these things in C++, Eric, you can put like double square brackets around things, and you can indicate something like this function never returns. And that's okay. Don't worry about it. Or you can deprecate something, which will give you a warning if you use it. No discard means if the person who calls this function doesn't pick up the return value, give a warning. Maybe unused is not what I was looking for, but like, if the thing isn't, because compilers will give warnings if you don't use things sometimes. I actually have those warnings turned off because they're stupid. I'll usually get to them, but likely means a branch is likely to be taken, unlikely means it's unlikely to be taken. So yeah, I don't think it's necessary for this thing. So I'm just gonna note, by the way, this will probably never happen. Okay, so let's see if our code still works. No. Okay. All right. So that's because we can't do this anymore. All right. So, dot C. Perfect. How many lines of errors was that? Quite a lot. Look at that. Never change C++. Never change. Okay. So our code's still working there. Let's change it over to map 2. Yeah, C++. Yeah. Oh, you forgot to add a .c to something. 500 lines of error messages. Just how it is. Be like that. Yeah. Oh, this. Remember, I combined the map, the original map. So the original map was a vector of characters, and then I made a status map, which is this thing here, which is holding all the different directions light has passed on each square of the map. And I combined them together, and so the original map is this guy here, the character at each spot. And so I didn't add the .c down here because it's still my original code over here. So instead of reading that, we just got that. Word count was 180 lines of errors. Not very helpfully. Not 180 helpful lines. Just 180 lines, and then you have to just figure it out for yourself. It's not helpful. All right. That is legitimately the worst part of C++ is template substitution errors like that. Okay, so I think we're in a pretty good place to get going on the actual code. We're loading the data, and we've got a map that has both the original character and keeping track of which way light has passed on it. Keep track of which way light has passed over it. This will stop infinite loop. Okay. All right, so let's shoot array. Let's do this. So shoot array, and then shoot array, and then we'll just print the map again. Just see what happens. Okay. Yeah, okay. So let's shoot array. Let's see what happens. Okay, so we're gonna start here, and then we've got our direction enum, which I guess we don't need for you, even though I feel like probably could have used it. All right. So you just print a map. It has no functionality. The map has no functionality. It's currently a 2D array of characters, Tofin. So I just made a class. I'm making a vector of, originally it's a vector of characters. It was just, the data here. The data here. But what happens, Tofin, because you just joined us, we're going to shoot a beam of light. And the beam of light's going to hit mirrors, and it's going to bounce around the map. And you can set them up in such a way they're going to go in a loop. And then you want to not loop forever. And so I made a class that tracks which direction the light has already passed. And if the light's already gone that way, we can just stop so that we don't infinitely loop. Okay, but it's currently not doing anything. The only interesting thing I've done is I've written a double left arrow operator for it, so that if light has passed in like multiple directions, it'll print a number, because that's how they did it here. Like they show you light's passed this spot twice, and if it's gone down, then it prints a little V. If it's gone up, it does a little caret, that kind of thing. That's the only interesting thing I've done so far. Everything else is like loading. You know how to load a file, right? And it's loading a text file. That's it. So you're not missing anything too important. Now we're gonna get to the actual heart of the code. Let's shoot a beam. Let's shoot a laser beam. All right. Okay. So first things first. We need to check for infinite loop, right? You guys remember that from 26? Check for base condition. Check for stopping infinite loop first. Okay. So if the beam of light is traveling north and our current spot says, hey, we've gone north from this direction before, return. You're done. Recursion. Yeah, we're going to be doing recursion. Okay. So if dir equals north, and map dot row dot at row dot at column dot north. It's true. And we return. Makes sense. So if the beam of light's going north and we've recorded on the spot, now we have no way of setting that yet, but then we're done. And then we're just gonna do this again. I probably should have written a vector, as I don't have to type this 4 times every time. I'm in too deep. All right. I could have just looped, because these are integers, right? And this could have just been, this could have been a vector size 4. Okay, anyhow, typing, yay, there we go. All right. All right, so this will stop our recursion. Double check, north, north, south, south, south. Okay. So this is gonna stop our infinite recursion. Now, we're gonna write down, mark, you've traveled this way to stop infinite. Just do that. There. There you go. So that'll handle all the infinite recursion and also update the map every time we visit a place. Okay. In fact, if we do this, don't need the word count anymore. Ooh, it went all 4 directions. Ooh, yeah, that's bad. Right. Always test. Now I really wish that I had used a for loop. Now I have to write this 4 times. Yeah, you can use the vomit emoji again, Jofin. I made that a problem for future me, and now I am future me. Tim Scott says, okay. There we go. All this code should be in a 4. Okay, whatever. Am I going to keep complaining about myself? Maybe. All right. So now let's test it. So basically, if we're going north, we either return or we mark it that we've gone north. And now it works. Cool. It's not, the laser's not traveling anywhere, but it works. Yeah. When it's too short to bother using a macro, but long enough to be annoying. I know. Like 3 and 4 is like right on that cusp of like, you know, like when I'm doing like physics stuff and there's like an X, Y, and Z, it's like, do I want to make an X, Y, and Z, or do I want to make a 3-element vector that I can loop over? You know, 4x4 is like just on that verge of like annoying, you know. Okay, I got no answers for you. Semester's over anyway. Right. So now, here's what we do. We recurse. In fact, we probably bake it into this. Yeah. The other thing we need to check for is bounds checking, right? So if row is less than 0 or row is greater than or equal to map.size, or column is less than 0 or column is greater than or equal to map.size. Again, we're assuming a square map, which is not a great assumption, but you know, we control the maps here, not the user. So technically, we should check for rectangularness, but it's fine. We do map 0. Then at least, assuming all the rows are the same size, that's a little bit better. It'll handle rectangles, even though all of our maps are square. Okay, so what we're going to do is just recurse in the direction we're going, maybe. Bonds checking. Nice. Okay. So we mark the current spot, and then we can just recurse all the way down. We don't even have to use a for loop. Yeah, how about that? So we're not handling mirrors or anything, but let's try it. Okay. Yeah. Okay. So we'll just shoot array, and if we're going north, then it's going to be row minus 1, same column, north. Who needs for loops? When you got recursion, right? I told you guys, I was in Seattle, and I met a guy who learned on Lisp, and Lisp doesn't have for loops by default. And so he learned recursion as his standard way of doing looping. He didn't do iteration at all. He did loops, or he did like his loop was recursion. So west is column minus 1. East is the one that we're actually testing. So I'm gonna try to get this one right. Okay. That's all he did. Recursion was just natural to him. Like, he didn't understand for loops, but recursion came naturally. And so this east. And here we go. Let's shoot it. There we go. Laser beam shoots to the right. Boom. So maybe if the spot is a special character, we should draw the special character still. That might be a good idea. Yeah. Make it a little more reasonable. But good. At least, yeah, we're shooting a laser. No for loops. Neat. So if the character is not equal to dot, then we will just return out the character. Nope, I didn't like that. What's wrong? There we go. So that way the the mirror comes through. Just put a little divider there so it's a little easier to see the before and after. So that's the before, and then that's the after, and you can see our laser is so powerful that it's currently going through the mirror. Okay, so what was the point to make it recursive? Well, it's going to be nice because now we don't have to do for loops, having the photon travel. And... Thank you. Who added a soundboard to Discord?
My apologies. That was the entrance thing. I forgot to turn it off.
Good to see you, Lawrence.
Good to see you too.
Are you bad to the bone?
Yes, that's the plan. Yes. I saw Advent of Code. And I'm like, it's Midnight 30. I've been doing nothing but C programming for like 2 hours, so
Nice.
I'll take a look.
Well, join
I
us. So,
hate my.
have you seen this one? Have you
I
seen this? You shoot a laser beam and it bounces off mirrors and stuff.
Oh no.
Okay.
No, I haven't done advent code in years.
You have not done evident code in years. Okay. Well, it should be fun. We're getting to the good part now. So right now we have a recursive solution that can shoot a laser beam. It doesn't reflect off anything, but we've loaded a map. You can see like that's a mirror, and so what's supposed to happen is the laser beam is going to come over, hit the mirror, and then go south, hit that mirror, and then head west. That's what we're supposed to do. And currently it doesn't reflect, so we need to add reflection code into, not like Java reflection, but like actual physical reflection into the code. And so I don't think it's going to be that bad, actually. So what we need to do, and again, I'm regretting life choices because I have 4 copies of the same code for traveling north, south, east, west when it could have been a for loop. But
learning moments.
I've only complained about this about 30 times. So. And who designed it? I did. So. All right. So
blame the designer. Points finger back.
Get blame. Oh, okay. So what you need to do is have the code reflect off of mirrors and split on a splitter. So there's only 4 symbols that the light can interact with. So a mirror is a slash, either front slash or back slash. And then the splitter is actually, if you hit a splitter from the side, then it launches beams of light 90 degrees to the left and right. And so if you have a splitter that is parallel to you, like if you're traveling east and you hit a horizontal splitter, nothing happens. So there's actually only 3 symbols you need to worry about in each of the 4 directions. There's 4 symbols, of which one of the symbols you will ignore in each of the directions. So, and then it could be open space. So we can just actually
Yes, you could make it a for loop, but it makes more sense to write it out individually because you have one character that you ignore.
Yeah, you know what? I could use another enum, but I'm not going to. Let's just do this. Okay, so I feel how properly should I do this?
About as properly as someone who's not getting paid to do this. Let's phrase it like that.
Yeah.
Wait, are you getting paid summer school or winter school hours for this? So
no.
Do it as hard as possible.
They didn't pay me. I'd teach for free. It's not true. And don't tell them that. But
no, there's a reason why you teach the summer game design course.
I used to teach game design for free, and then I was like, wait a second, they would pay me for that. Yeah, sign me up. That's how I get my my graphics cards paid for. Okay, so const char open equals dot. We're gonna do this properly. Let's do this. So it'll default to open. And let's do this properly. Okay. Yeah. Okay. Left mirror. I don't even know how to say this. How do you describe a mirror?
You can describe it as like
left mirror, left tilted mirror.
Yeah, you could do like you put the symbol in the name.
I could. Oh yeah. And then I can't help you with names, dude. They're the hardest thing in computer science. Okay, front slash.
I'm just reminded of back in my robotics days in high school. Someone like the teacher, high school CSI level, not super into it, but she like has some stories of it. She's like, whatever you do, be sure you're careful about your variable name. It stuck with me to this 8 years. It's one student at one point in time. She coded most of the program for the robot, and then she had to leave to go to to go do something for a few weeks. and she named a bunch of them random names like fish taco, beef taco, pork taco. No one had any idea. They had to call their mom halfway through the thing. Is like, can you explain? We have no idea what any of this is. You did not comment anything. I'm like, sticks with me. All those fun stories.
Cool mirror. Yeah, Eric earlier was saying how he likes the name is, what was it, swag vector or stink vector. Yeah. Okay, that's maybe better. I don't know. Honestly, working just directly with the characters would have been fine. Okay. In fact, it might be more prone to error now. I don't know. Not convinced on this. Okay, so anyhow, so if the spot is open, so if const charge equals map dot at row dot at column. Technically, we don't need this. Column. Okay. Because we've already done the bounce checking like here, right? So we don't need to do it again. Okay, so that's the character. And so if the character is open, then we just move to the east because we're traveling east. Yeah. And in fact, we could switch. You guys want to see a switch?
No.
No? You want to see a switch?
Mm.
Yeah? I don't. I hate switches.
The worst.
I remember. They're literally the worst. Okay, switch on sh. No, I
just put an or in the if statement. That's all you need to do.
This should be a enum. Nah, whatever. Okay. So if it's open, and then always forget your break, people. People always forget that when you do a switch. So case open, case closed. No, case. So actually, you can do this. Case open. Case horizontal splitter. Also, because it doesn't interact with the horizontal splitter. It'll just keep going. Okay, now if it's a left case left mirror, then we will go. So we were traveling east, and then now we're going to go south. So we're going to do array on the row below us, same column, and our direction is now south, and we break. Don't forget the break, people. And then if the, so it's 1, 2, let's see, right mirror, it's going to go up.
I think we have a question in the chat of why are switch cases so bad.
Why are switches so bad? Literally every time somebody posts something on CPP questions and they've got a switch statement in there, I immediately just like look at it first. Might have like 100 lines of code. I'm like, let's see if the problem's there. And you know what? You know what? A lot of the times the problem is they break the rules of the language. You notice the use of colons here, right? These are go-to labels. There's actually some really horrible, nasty things you can do with them. Like you can do a switch inside of an if statement, and it like
he's pulling up the specific link I remember. As an assembly connoisseur, I like labels, but at the same time, I understand how dumb they can be.
Yeah, so look at this.
I remember.
So you see how you have a do open curly brace inside of a case. Yeah, that. Do you understand what I mean by it? Kind of like breaks. It kind of breaks the normal language, and no, there's no breaks in any of these. And so when it does one of them, it does all the ones below it. So when it's case 0, it actually issues a do with an open curly boy, and then when you do this one, it does finally the close curly boy, and it generates a number of copy commands based on the number of bytes to copy. And so now 0 as in when you do a modulus 8, you have 0 left over. So it's divisible by 8. So it copies 8 bytes at a time. And then if there's an odd number left over, then it will jump down to like 3 and then do 3 copies. But yeah, and switch statements only work on integral types. They don't work on anything else. You can't use an if statement to like if you're trying to do if anything that's not an integer, like it doesn't work. So welcome to my TED Talk.
The only place switch statements belong is in hardware scripted languages, which none of you will ever look at, so don't worry about that.
Switches only work on integer types, and they only do comparisons. They don't do ranges and things like that. So they're highly limited. They break the language. They are more performant, and if you need to squeeze every last ounce of performance, the nice thing about a switch is it can jump to the spot that it's trying to get to instead of doing if. You can leap there, and so switches can be more performant, especially if you've got like 50 different if else. But I don't teach it to CSci 40 students for a reason, and that reason is, well, I just showed you. So
we don't want everyone cosplaying as the mascot in CSci 40. That's why.
Yeah, exactly. So what is the point of a switch if you can just use if? Exactly. Like I just use ifs. But here, this is kind of nice because, I can actually cover 2 of my test cases or 2 of my possibilities in sort of like one if state. I don't know. I'm doing this to show you guys. All right. I wouldn't do this wrongly. All right. Left mirror, right mirror. And then for the vertical splitter, now it's flavor country. Vertical splitter. Now we're going to do 2 recursive calls. And we're going to, if we're going east and we hit a vertical splitter, we would go both no. I didn't finish this one. Row -1 north. That was almost a bug there, huh? Once you get me talking. Okay, and then you can have a default on here. Die, or something like that. It's like if a case comes up that you didn't handle, see out unhandled case. All right, and exit. All right. So that is that. So if we hit a left mirror, we go down a row and head south. We hit a right mirror, we go up a row and travel north. We hit a vertical splitter, we go both north and south.
Quick question from chat.
Yeah.
It just part of the reason why it's so confusing is someone asked why both the colons and the semicolons.
Well, the colons are for the cases. The colons are for the cases, and these are literally go-to statements or labels, which you'll learn about in 45 next semester. Let me show you something fun, and by fun,
it means horrifying.
All right. Wait, sorry, it's HTTP : / Sorry. Okay. Did you know you could type a URL and it's valid C++ code? Infinite loop, right? So what's happening here is we've got a label called HTTP, and we see out hello world, and then we go to HTTP, and it jumps back up there, and it's an infinite loop. So that URL there is a label followed by a comment. So you can technically paste a URL in outside of a comment, and it'll work once. If you try doing this again, then you've got a duplicate label, which you can't have. So, yeah, this is why it is a colon, because labels are colon. They have a colon to indicate their label, and so all this stuff you saw up there, these are labels. So let's see what happens now. Cool. So it travels right, it bounces off the mirror, and it travels south, and nothing happens because we've only handled the code for traveling east. But that worked. That's cool. One digression on how switch statements are terrible later, right? All right, so now all we have to do is just do this for all 4 directions, and we're done. I'm not going to complain about my life choices anymore. Let's just do this. All right. So let's do south maybe next. We'll just test. We're going to test these one at a time. I'll add a horizontal splitter here. I'll add a vertical splitter here. And everything goes right. Ooh. Oh, yeah, that's correct, actually. Yeah, that's fair. That's fair. Okay. But it did ignore the horizontal splitter. Okay. So maybe vertical slash. It's going to bounce here and it's going to come up. Maybe we'll do a horizontal slash there or something. There. Okay. We'll try that. Make a little test map for the thing to bounce around. Okay. So let's handle the south direction now. So south direction, this is the code for open. I'm just going to comment that out. I'm just going to bring over this switch statement. I'm going to copy this whole thing here. Paste. And so if we're heading south, horizontal splitter is actually something we're going to care about. Vertical splitter, we will ignore. So if traveling south, it just passes right past the vertical splitter. And we're going to go south, so we're going to go down 1 column and keep heading to the south. Guys got to call me out on these things. Okay. Go down a row and travel south. We hit a left mirror when we're heading south. Now we're going to go left mirror. Left mirror. This is why I didn't want to create the backslash. Okay. Left mirror is this way, so it's going to bounce to the right. So column to the right and travel east. What happened? Travel to the east. We hit a right mirror. It's going to bounce and travel west. So same row. On the left, traveling west. And if we hit a horizontal splitter when we're traveling south, then we're going to go both east and west. Like that. Let's try it. Bada bing, bada boom. There goes, there, goes through here. And we're ignoring that because we don't have any code for going west. So let's do the code for west now. Let's see how that shakes out. Okay, so if we're traveling west and we hit a horizontal splitter, nothing happens. Should probably copy the code for east. It'll probably be a little bit easier. It's going to be very close to that one. Okay, so if it is traveling west, then we go west. Now we're traveling west, and we hit a left mirror. We're going to go north. If we hit a right mirror, we're going to go south. And if we hit a vertical splitter, we go both south and north, so we're done. All right, test it. And there we go. We're bouncing. And cool. We got a number 2 now. So that's nice. Nice to see that works. And then the last case we need to handle is the northbound route. So we're going to use Mr. South over here. And copy you. Come over to you. Paste that. Okay, so if we're traveling north, vertical splitter and open keeps us going north. Left mirror and right mirror, I think, just get inverted. Let me check that left. Going north, we're going to go west. Okay, go east, good. And horizontal splitter, west and east, both cool, neat. And we're done. Cool, everything worked. Nice. 2 means that the laser beam has crossed that path twice. So, I'm not sure if I can set up. I'd have to think about it. Like, you could get it set up more than twice. I'm not sure if that's possible, but either way, it's handled. So now the last thing we have to do to pass the. I should probably test all of the possible combinations, but I'm just going to go for it because I feel pretty good about this right now. I feel like about 80% confident this code's correct. So is it? I don't know. Let's find out. So I'm going to switch the map out. So I haven't tested all of the cases for all the directions. But I'm just going to throw in the original map and then see if the thing we get is what we're supposed to get. So here is what we're supposed to get. Here's what we did get. And yeah, I think we got it. Cool. Neat. All right. So the last thing we have to do now is just count how many squares were touched. So, I mean, you say it would have taken you a week, but you have to approach it methodically. You know what I mean? So start off with those base cases. Like those base cases are now like embedded, like like that code that stops it from looping infinitely. That's what I always start with. So this code, if I did it right, it shouldn't have any infinite loops in it. And also the bounce checking at the very beginning, which I should have put in from the beginning. Start with that and then expand out from there. If I forgot like one of these things, oh Lord, have fun debugging that. You know what I mean? So yeah, you have to really think about it methodically. And that's one of the reasons why, Eric, I tell you to take 26. Because even though it's like, oh, it's a math class, like when you do proof by recursion, proof by induction and recursion, I should say, then you start thinking about things like this, like, all right, how does it stop? How, what's the base case? What gets it to not loop infinitely? Right? So, and then work on just like one of the directions, right? Like work on just east, and getting that to work. And just one step at a time. That's why I'm recording this for you guys, is just so you can see, like, if I was just doing this like on a timed event, I wouldn't be talking to you guys and complaining about switch statements. I'd just be like doing it. But my process would be the same. Just building it up a little bit at a time, testing, building it up a little bit at a time, testing, like I typed this stupid file name wrong, right? And that was a problem that a student had in 40. His code was fine, but his file was in the wrong directory. He moved his CC file, and then his code was crashing because when he was trying to open up map1.txt or whatever, it wasn't in the directory anymore because he moved his file that had his source code, and he didn't check for it, right? He didn't say like, hey, if the file failed to open, print, file not found or something like that, right? Which I'm technically not doing here, but at the same time, I am printing the number of rows. And so if I got a 0, which is what I got the first time, I went, the file name's wrong, right? So you got, Don't trust anyone, not even yourself. Okay, so the last thing we have to do is count how many squares were touched at all. All right, and so just make a function. We make a method. It's been touched or something like that. I don't know. It sounds bad. Did I tell you guys about hard touch and soft touch? It's past midnight. Reed, you heard about this, right?
ACM After Dark.
Reed, you heard the story, right? No, it's not touching kids. What are you talking about? It's disgusting.
No, I think I know. I'm ACM After Dark, just after midnight. But I think I remember it. In 2 years.
We were at the beginning of every semester. They bring all the professors in, and they like talk at us for like 8 hours, and it's exciting. It's fun.
I mean, yeah, you had a double convocation this semester.
What was that? Yeah, we had two convocations this semester.
Yeah, you had the district one, and then you had.
I unfortunately couldn't make either of them. It was
oh my god,
one of the great regrets of my life that I unfortunately couldn't make either.
I have one of their bags. They gave out some cool swag at the district one. That was fun.
They did, yeah. But at one of these things, they had the counselors come up, and they're like, "We're gonna tell you about hard touch versus soft touch on your students." And Eric, you can ask your professor friends. I know you're friends with a couple of the math professors in the department if they remember this, because we were all sitting there out in the audience like, excuse me, what? And we're like all like looking at each other like, I think you guys probably need better words for whatever it is you're about to say to us. And so a hard touch, say a soft touch, is like if the student's struggling, right? Then you soft touch them, which means you send them an email and be like, "Hey, are you doing okay? Is there anything I can do to help? Things like that." Then a hard touch would be like bring them into office hours and be like, "Look, you need to start studying. You need to do your essay. Let me help you." That kind of stuff. So, that's all that meant. But the phrasing of it was not well thought out. Let's put it that way.
I mean, to be fair, you have hard touched your students before when you used to do the right. Extra credit events.
This is being recorded, Lawrence, for YouTube. So I'm
talking about when you used to give judo extra credit. Those were fun.
Yeah. Okay.
When you used to toss students around.
I have to pause the recording here. I've not tossed students around. What are you talking about? Okay.
You have. When you used to do the extra credit, we beat you in a judo match.
I did not beat students in a.
Well, when they were supposed to beat you to pass.
I'm pausing the recording now. All right. So, yeah, Eric's losing it. Yeah, Eric invited me to do jiu-jitsu today. Actually, I couldn't make it though. Anyhow, so for the people at home that want context on this, I used to teach martial arts on campus on Fridays. I'm not beating up students or hard touching them or whatever. My goodness. Okay. Yeah. So we're going to create a function called bin touched. And basically, if we've gone over it in any direction, north, south, west, east or west, whatever, in any direction, then it'll return true. If all of them are false, then we return false. And then what we're going to do is just count how many squares have been touched. And that should be our answer. And that'll be it for at least part one of this. So let's count, touched. Need a little function here called count touched. Actually, I'm going to pass in the map because I made it a global because it's terrible coding style. All right, count touched. All right, and we are going to say for auto. Let's use the Int count equals 0 for every row in vec. For every row in map. For every column, which is a symbol, whatever it's called. Okay. If call dot. Let's see. It's a status, right? Why is that not showing up? If that column's been touched, then count is incremented. And then why is that not working? Every row on the map. What are you? It's not marked as const. Thank you very much. Right. Turn count. And that should be it if everything goes right. 46 is our number. 46 is our number. All right. So far, so good. Moment of truth. Now, the problem with Advent of Code is that if you don't get the right answer for the big one, yeah, sucks to be you, man. Like that's when it gets really tricky because it doesn't tell you what the answer is and it doesn't tell you what you did wrong. So let's just switch out the map with the big guy. By that I don't mean Joe Biden. And we got 8323. That's the answer here. And let's submit it, and we got it right. Cool, first time. Neat. All right. All right. Continue part 2. All right. So, as you try to work out what might be wrong, the reindeer tugs on your shirt and leaves you doing your right control panel. Question of buttons. Any edge shell. And heading away from that edge. You can choose either of the 2 directions for the beam. If it starts in the corner, the beam starts in the bottom right. Start heading either left or upwards. So the beam can start on any tile in the top row heading down, any tile in the bottom row heading up, any tile in the leftmost column heading right, or any tile in the rightmost column heading left. To produce lava, you need to find the configuration that energizes as many tiles as possible. The above example, this can be achieved by starting the beam in the 4th tile from the left on the top row. So starting from here, something like that. Using this configuration, 51 tiles are energized. All right. Find the initial beam configuration that energizes the largest number, and then how many tiles are energized by that one. Okay. So now we, instead of just calling, okay, this is actually nice. Like a lot of the Advent of Code stuff, this is my first one that I've done this year, but last year, a lot of the Advent of Code part 2s required you to, like, substantially rewrite your existing code. This is nice because all we have to do is just, instead of we just keep our function. We don't have to change anything. All we have to do is shoot array, not just from one spot, but from every spot, see which one's the maximum, and then we're done. So we're gonna have to reset. We're gonna have to reset between maps. It's gonna be annoying. Slightly. Okay, so void reset. It's not gonna be const. So north equals false. The character should stay the same. Okay, that's it. And then for the map, let's just make a reset map function or something like that. And probably just okay, so every row for every column, reset that square. That'll clear the touch count. Any other comments, Lawrence?
Are you sure you want me to comment on things?
Yeah. Which one of the martial arts classes did you go to? Lawrence?
Say that again.
Which one of the martial arts classes did you go to?
None of them. I just remember you telling about the stories about it during the middle of COVID.
Oh, that's right.
When I unfortunately I didn't know you back then.
Yeah.
Even though I was part of the crowd of like, you should really take Kearney, you should really take Kearney. Then COVID hit. I was like, damn.
Yeah. Yeah.
Going on for 45 and
yeah, it's like every Friday. It's like for every Friday I was teaching martial arts almost. This last year was Latin dance somehow.
Latin dance has always been fun.
Yeah, no, I enjoy it. Yeah, Eric, I was teaching. Yeah. What was that, Lawrence?
I was saying when I had CSI 1, I came to a fair few of the extra credit events, which was fun.
Yeah, I enjoy it. Okay, so what we need to do is for each of the 4 edges, we need to shoot a beam from the edge and then reset the count. So we can just do something like this, like int max touched equals 0. And then use 4 different for loops. A more clever way of doing this, but whatever. For int I equals 0, I is less than map size. Again, we're assuming a square map. I plus plus. So can merge them all together. There. Okay, so int touch is equal to okay, so we're going to shoot array. We're going to first reset. We're going to reset the map first. Then we're going to shoot array, and so we're going to shoot downwards, or let's do east first, I guess, because we're doing already east. So it's row 0, so it's going to be row I, column 0, traveling east. Thank you, Commander of Conquer, never change. So we're going to reset the map. East, all the way down to the bottom. And then we're going to count how many were touched. And touched. Let's go look, count, touched. And then if max touched is less than touched, then max touched equals touched. And I'll just copy and paste this 4 times. Whatever. Okay, so east, and then we will do map dot size minus 1. So we're going to come in 1 from the east, traveling west. So that's going to be the rightmost column, traveling west. We're going to shoot 1 going that way. Then we're going to do southbound. So starting at row 0, column 1, column 2, column 3, column 4, coming downwards south. And then on the bottom row, it's going to be map dot size minus 1. So the bottom row, I traveling upwards. We'll just print out max touch, I guess. Let me try this on the sample map first. And so 51 is the max. 51. All right, well, if this doesn't work, I don't know what to tell you. All right, so here we go. 8491 is the maximum. There it is. Part 2. Easy. Let's go on, Betancourt. You missed the discussion of hard touch versus soft touch. The unfortunate choice of words the counseling department used. I also went on a rant about switch statements. That was fun too. Or when the coffee ran out. So, Eric, were you in 26? You sat behind me, right? Are you guys just now like recognizing each other online through a semester? Sitting next to each other.
Oh my god! It took. I told you, right? I had Aaron worked with me like the first semester. Fresno City was in person for tutoring for like an almost entire semester. Then one day he was randomly talking about taking a Seaside class, and I put two and two together that the random dude on Discord with a Chinese name and the guy who was speaking Chinese and talking about Seaside at work were the same person. Almost an entire semester.
So here's part A. It just shoots a ray east. And then for part B, we just shoot rays in every direction. This code pattern is something you guys should probably be familiar with. Going up to size -1, like I0, 0I, I, size -1, size -1I, all 4 combinations, all 4 directions. And then this pattern of like if nope, did I break something? Yes, I did. Okay. If max is less than touch, max equals that pattern. These could all be combined together if I wanted. So we only have to do 1 for loop instead of 4, but whatever, it's done. I'm not going to go through a process to minimize this. Technically, print map doesn't need to take vec anymore. It can just be map because I made it a global because choices. Yeah, overall, how would I simplify this though? I realized halfway through the class my name was actually Tofin, not Eric. You'd look up and Cranny would not look at me, and I was so confused. It's funny. Yeah, I don't know. Like, I feel like we got 4 directions, and we've got 4 different symbols that it can interact with. And they all go in a different direction, right? If you're going east, it goes up. If it goes right, it goes down. If you're heading south, it goes west. If you're heading north, it goes east. Probably could minimize this somehow, but I don't know if it'd still be readable with this. So yeah, I know. I'm fine with this. I think the key to success on this one is stopping, like thinking from the beginning about infinite loops, right? Because you can't just assume that Advent Code's not going to give you an infinite loop. They're going to set up mirrors. They spin around forever or whatever. So you gotta always make sure whenever you do recursion, bake those base conditions into it. Start with that, and then I could have kept these as 2 different vectors. Maybe one is a vector of characters, one is a vector of statuses, but merging them made it a little bit nicer for this part right here when I was printing out the character or the count. And so by putting them together into one, it made life a little bit simpler. The actual main's pretty small, honestly. Like this, get rid of that. And that's base. This was basically part A. Load the map, You don't even have to print it technically. And then just shoot array. See what happens. Array and then count. Count touched. And pull that part out. That's part A. And then part B. Fortunately, it's nice. You just reuse your existing code. And don't need math anymore. That's it. Yeah. Overall, I'm pretty happy with this one.